Hey Finxter, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about the Python pass keyword. So this is just an introduction into one of those basic Python keywords which you should understand because you see it a lot in practice. And this keyword, although it's not like strictly important for your code, you will see it a lot and when writing idiomatic Python, so when working in practical Python projects, you will actually encounter this keyword pretty often, and you will sometimes need to use it in order to write more Pythonic and more idiomatic code. So let's have a look where the pass statement actually applies. So first of all, so on a very general note, the pass statement does nothing. Okay, so it does nothing when executed, but you can use it as a placeholder for future code so that you can focus on the high-level structure of your code first before implementing the details later, right? So this is like the most important use of the pass keyword. So for example, if you have functions, loops, class definitions, or if statements, basically all of them, they require at least one statement in the indentation block. So you need to have at least one statement in those blocks. And if you just want to get a high-level picture of the code first, defining the structure and the different names of the functions and the different definitions, but not yet implementing the body, because implementing the body, it takes some work, and you first of all, so before diving into the nitty-gritty detail, you need to have a high-level understanding of the code first, right? So let's have an example. So say you want to implement two basically functions, read image, and you can already see how I use the keyword pass and recognize image, and you want this to take a number of pixels, can be an array, something like this. And then you can, for example, say first you create a pixels image by reading the image. So here you use your function image, which you have already defined here. And then you take the image you have just read, for example, from a file, and you call the function recognize image, and the recognize image, and you pass the pixels array into the function, and you print something like your image contains, and you print the result, something like this, okay? So you can already see this is like working Python code, but you have not done anything in the functions yet, because implementing those functions, this can be a very complicated function itself, right? So to recognize an image, to like analyze the contents of an image, you need to do some machine learning and stuff. So this is like the implementation is not easy, but you can already implement your program like this on get a high level idea, get a high level picture, implement all the functions you will need, and you can then revise the program and so on. And even like you could even test it and later, for example, do some basic image recognition and then improve upon it over time. So this is like it's a good habit when writing code to actually first define the function names and define the function you need and the classes and so on, like the different structures and code blocks, and then and just fill in the blanks later, right? So in this case, if you execute the code. Results, I have called this result. So if you execute the code, you see your image contains none. Okay, so the code does nothing yet, but it works. It doesn't raise an error, right? So and then you can like go into those functions later and simply replace the pass statement with your custom code. So another example is so basically what you are doing is if you wouldn't use the pass statement, so say we just get rid of this, then it is actually not working code. If you try to run this code now, you see Python gives me a syntax error, so it doesn't even allow me to execute the code. It says expected and indented block. So basically you always need at least one statement in the function body and in this indentation block. So for example, what you could also do is to have a comment like your code here, something like this. So this would basically fill no, actually, it doesn't work as well. Okay, so I didn't know this as well. So so you like even this wouldn't work. So actually, you need to have a statement. You could also have the return statement, and now it works again. There's no exception, right? So the return, it just returns nothing. Basically, if you only have the return keyword without without like a num without returning any object after the return keyword. It simply returns per default none, which is actually, even if you don't have a return statement, if you have a pass value, then it would also return none. So in both cases, both are basically semantically identical, but I think this option here is more idiomatic, more Pythonic, because it explicitly tells the reader of your code something comes here. So there's still something to be done. Okay, and yeah, this is basically the purpose of the pass method. Another example would be the following. If you have say you want to define a class image with somehow the same purpose, so an image class has a constructor. And you can see I already defined the argument list as well, and the names of the methods to be used in my class. For example, I may have a method recognize, which I can then call on the image, and this should do something. And then you can have a method read from file. It takes a reference to itself, as all methods do, and then a file name, for example, so that we can read this image from a file. And we have the keyword pass, and now we can, for example, from outside we can create an image, and we can print image recognize, something like this. Okay, maybe we first have to call image read from file, and then we have some file name like file in.jpg. It's an image after all, something like this. Okay, so now you can see this high level code again, it works, so we can execute it. It gives me an image object like basically it's so because recognize, no, it's a function, so we need to call the function as well. Now you see the output is none as well. So it works, it is working code. The pass keyword, it works, but it doesn't return anything, it doesn't do anything. And this is like, now you can go into the details after you have finished the high level idea. So implementing the high level idea, you can go into the details. And now basically you have broken this big problem of doing some image recognition or so into smaller problems. And now you just like, you need to, for example, implement the functionality, read the image from file and recognize using some external libraries or so. Okay, so this is one common use, but then there's also another type of use. This is a bit different. So for example, you can implement some dummy classes, and this is called, like, it's related to duck typing in Python. So we create a class called myData, and this is just meant as a wrapper class where you can just store in any data. It's like a flexible class. In Python you can later change each object. So for example, you can do the following. So we have data1, and now we create an object, myData. Say we have the same for another object. Let's call it data2. So now we have two data objects, and basically now they are empty. They cannot do anything, right? Because you have only like used one statement pass, which does nothing. So we have this object, this myData object, is not capable of doing anything. But now what you can do in Python is to dynamically associate some new attributes and values of those attributes. Even methods you could later add to any data1.b 42. You could even associate methods to an existing object at a later point in time. So you can see you can basically store any data in this object after you have created it. And here you don't have any attributes in the object when creating it, but you can associate those attributes later on. It's not like particularly good style, but sometimes you just want to do this, right? So for example, now we have can associate arbitrary attributes and attributes name to this. Data2 friend. I'm just doing some dummy stuff, and now we have two types of data items, right? And data2 and data1, they are quite different. They have different attributes. Data1 has attributes A, B, C. Data2 has attributes enemy and friend. And now we can simply do something like print data1 A. We can, for example, pass them around or send them over the network, over TCP socket or something, yeah. And you can then print the attributes. For example, in this case, it would print hi friend. Okay, so because we access data1a, which is data1a, it is defined as hi, and then we also print data2 enemy, which is defined as friend. Okay, so something like this you can do. This is quite common. It's also quite different because now it does not read like a to do. Please change me later. It reads like I want to have this empty wrapper object, which I can then later dynamically modify to my needs, right? So this is also quite common. I would say the second most common use case of the pass statement. And then of course you can do something like this, user input. So for example, you can also use it in an if statement. So for example, if user input is 42, you can print something. And then if you are not just sure, so in your program, for example, you do so here you take user input, you check whether the user input was 42, and then you print yay. So it's like a congratulations for the user to get the right input. But then you also, like, you have a mental note in your head as a programmer, you want to do something if the user input is wrong, right? But you don't want yet to implement it. So don't want to implement it yet. You want to, like, because you just have an idea, you are in the flow, so you want to just keep on coding. So you just add the else pass statement here, and this tells you later, okay, I have to do something here. I want to have an else branch. I should not forget about it, because if you just implement it, I mean, something what many programmers are doing is something like this: implement else branch here, something like this. But it's not like, it is not so Pythonic, right? Because you could just implement the else branch and do nothing. And this is like, it's like a to do, but it's a workable to do. It gives you the structure is already there, and the logic follows later, right? And so if we run the code, we get we should have some user input. For example, if we have a 3, nothing happens. If we run the code again and we type in 42, it gives me a. Okay, so this is also one common approach, and I would say one common approach, the last one we are handling in this video, where we will use Python pass, is for some exception handling, right? So say you have a certain list of numbers in numbers, and now you iterate for number in numbers, and basically what you want to do is print result, something like this. So print result, and we have, say, string value. Let's just make it 1 divided by number. Okay, something like this. So if you run this, it works for the first 2 numbers, like so, because we can divide 12, so we can calculate 1 divided by 12, and 1 divided by 1 is also possible, but we cannot divide 1 divided by 0, and in this case it will raise this exception 0 division error. So what we can do is to wrap this in a try except statement, and so this again is a block. So except, for example, we can have exception as e. So you want to do something here maybe, or maybe you don't want to do something. And if you actually don't want to do something, if you want to just ignore the values where it doesn't work, you can do something like this. You can have the pass block here. So you cannot do nothing, yeah, because now again Python will give me this exception. So it expects at least one statement in the indentation block. So what you are doing is you use the pass statement, because you want to, like, if it doesn't work for some reason, you want to just ignore it. You would just want to print all all inverse numbers, basically. So 1 divided by the number in your list, for which it works. If it doesn't work, you just don't care, right? So in this case, it runs through. It doesn't even give you a note of the exception, because you just want to ignore it. So this can help you implement some programs and increase the usability of your programs, and to make them more failure tolerant, right? Because now users actually more transparent, because users now don't even see that there was an error. Okay, so to summarize everything, Python requires that code blocks such as the if, except, def, class, and so on cannot be empty, right? However, empty code blocks are useful in many contexts, as we have seen. So in these contexts, when nothing should be done, actually, you can use the pass statement to avoid the indentation error. And theoretically, you could use any other statement as well, so like return or like print nothing, something like this. But most of those statements would have some side effects, or you can define a dummy variable or so, but they have some side effects. So now this variable is stored in memory, or you have to print something. This actually shows in the console. So in those cases, if you don't want to do this, if you want to be syntactically grammatically correct, then you should implement the pass statement, and if you don't want to have any side effects, of course. Okay, so that's it for this video. Thanks for listening to this video, and yeah, see you in the next video. Bye.